All right. So we have a table of the of these different homologous series and functional groups, and there's the structural formula, the name of it, and some ball and stick model, but it's not super important, but then what the name ends with. So an alkane has this formula, the homologous series, and its general formula is CnH2n plus 2. This is what it looks like. Or this is the functional group. Basically, an alkane has no functional group. It's just carbon chains, single bond carbon chains. They can be long, they can be short, but they have no other substituents. It actually says here only CC, only carbon, and carbon hydrogen single bonds. This is an example of what it looks like. There's the name ethane, but I'll get to the number, how to count just now. And an alkane looking like this. So you'll count the carbons 1, 2, which is meth, eth, eth, and what does it end in? Ane. So this thing is called eth, and it ends in ane because it is just a alkane, single bonded to carbons and hydrogens. If you look at alkenes, it's got a different formula, but these formulas are important to memorize. They can be asked. So if we look at their functional group is, there is a double bond between two carbons. It can happen once, twice, as many times as it once, okay? So looking at this example, first thing you do is you count the carbons. How many? 1, 2. What's 2? Eth. And because it's an alkene, what does it end in? In. So it's eth, 2 carbons eth. And because it's got a double bond, it is in. Ethene. Go to the third one. We have says unknown. Look. Unknown, meaning someone's trying to sell me something. Solid. Alright. Alkynes. So we have a different formula for it. You see there's a slight difference, and there's a pattern in how the formulas work. It's got to do with what the triple bond takes out a certain amount of hydrogen. So an alkyne has got a triple bond between two carbons. Here's an example. How many carbons in the chain? How many carbons? 1, 2, meth, eth. And because it's got a triple bond, it is an alkyne. Therefore, its name ends with the ine, so it's ethine. So what I want you guys to do, these three, I want you sort of like, group these three together like when you study or when you apply this rule. Those are very similar. Single bond, double bond, triple bond, right? I'll show you, you pair these homologous series up so that you can better understand or study them. Otherwise you get confused. Instead of having like 8 of these things to study or 9, you can just study 3 groupings and it's quite easy. Looking at the next one, you have haloalkane, haloalkane. Okay? So you have an alkane with a halo. What's a halo? Halogen. Halogen is group what? 7. So you'll have some carbon chain and you'll have a X, a halogen. Be a chlorine, a fluorine, a bromine, a iodine. I told you, yeah? The X can be a fluorine, chlorine, bromine, iodine from group 7. You can just write the group 7 if you want. Group 7. And taking a look here, let's see how we name this. How many carbons in the chain? This example. 1, 2 carbons. Meth, eth. But now you also have a chlorine on the end there. So it would be chloroethane. So you don't say eth-chloro, you say chloroethane. Okay. So that's important how to name it. So it doesn't have a special type of naming. You just go with whatever one of these 3 it is attached to. Okay. Chloroethane, chloroethene, yeah.
Is it ethane because it's single carbon?
Yes, yeah, that's why, yeah. But it was a double, would be chloroethene. Okay, it's going down to alcohols. I want to combine alcohols with absolutely nothing. All right, so so let's just keep alcohols by itself. I think that's a better idea because I want to combine, play with the carbonyls just now. So if you take a look here, we have a carbon atom is bonded to an oxygen, which is bonded to a hydrogen. This OH group is called this name here. It's called a hydroxyl. Very important. An OH group is a hydroxyl. Now, I'm quite naughty, and all the teachers are really lazy. So we usually do this. We say, there's a carbon, it's got bonded stuff, and now it has, we write this down. This is wrong. You mustn't do that, because if you take a look, do you see that bond there? Yes, sorry, you guys see that bond? That has to be drawn. Okay, don't leave it as a, don't be lazy. Don't do that, okay? I can do that, you don't do that. So we have to do that. So what do we call an OH group? Joshua, okay. Ria, what's our OH group called? If two carbons have a double bond between them, what do you call that homologous series? Ethane, incorrect. Who's going to help him? Someone help him. Ethene, correct. Okay, I just want to see if you guys are listening. Okay, so alcohol is pretty simple, eh? So if you look here, how are we going to name this thing? How many carbons? You guys see the pattern here? You count the carbons. How many carbons? What's the longest chain of carbons? We have two carbons. Meth, eth. What does we have an OH group, our hydroxyl group, which implies that it's an alcohol, and alcohols end with OL. So we have meth, ethane, ol. If you had three carbons, what would you call that? A three carbon chain, straight chain with an alcohol at the end, what would we call that? Propyl, no? Propanol. Yeah, just watch out for this this thing here. That AN does come in. It's actually yeah, just watch out. Just maybe just underline that little piece here. That's included every time. Okay, it's included every time. We'll get to the naming just now. I just doing like two things at once here. And then we have carboxylic acids. But I actually want to combine the carboxylic acid thinking to esters. You guys see up here, there's esters. So I don't know how are you gonna do this? Maybe just go like this is A, and then see like, so there's A for carboxylic acids, and up here we're gonna go again A for esters. So we're gonna compare these two to each other. Now you guys take a look and tell me, just looking at the functional group, what is the difference between a carboxylic acid and an ester? Very important question. Anything? Yeah, just give a guess. So again, the names are different, yes. Besides that, I mean, like looking at the actual structure, yeah. Okay, good. So you're saying by esters, she's saying there's this C double O thing. We'll get to what it's called now. The C double O part over here. It's between two carbons. That's what she's saying. By carboxylic acid, you also have a C double O, but that oxygen is bonded to a hydrogen. So carboxylic acid, the cool thing also here, this is how I remember the difference between an ester and an acid, carboxylic acid. What is an acid? You guys studied it. What is it? Proton? Proton donor. Can this guy donate that proton? Yeah. Can this guy, is this the carboxylic acid? Does it have a hydrogen it throws out? No. So the carboxylic acid will always end, there'll be like a long carbon chain maybe, like carbon, and it will end by the end of the chain. You'll have hydrogen sticking out there, because nothing can bond to this hydrogen. Eh? Let's take a look here. So there's a way to name carboxylic. Oh, but before I get there, now this C double O, you guys see that? I'm just going to circle it. This thing is called a carbonyl group. Sorry, carboxyl group. I think I spoke wrong there. Sorry, sorry, just ignore me for now. There, I just want to go to this first. Yeah, that's more advanced. Sorry. Do you guys see that word carbonyl group? Do you guys see that? That is this thing, C double O, the carbonyl group. So actually, there's some errors in this thing. I'll fix it later. But like that's a carbonyl group. Very important to know that. Like remember, let's ask Nichka, what's our hydroxyl group? Hydroxyl group. Anyone? OH. Your OH. And our hydroxyl group, if it's attached to a carbon chain, what does it make it? Yeah, but what's the homogeneous series called? The alcohol, yeah. Yeah, it's good. Okay, so if you have this carboxyl group, so which is like the whole thing, if you have this carboxyl group at the end, it will form a carboxylic acid. How do you know the difference between a carboxylic acid and an ester? What trick do we use? Acid is a proton donor. Which one's got the acid? Which one's got the proton, the hydrogen at the end? That's how I remember it. Will it work with you guys? Do you think? Because when I was in school, it wasn't explained to me like this. It was just like, just study it. It's not nice. So I figured out all these little, I hate studying this stuff when I was in school, so I figured these things out. So we got esters, and let's look at the naming quickly. So we have, for carboxylic acids, it will always end. How do we know it's a carboxylic acid? It has this carboxyl group, the COOH, at the end of a carbon chain. We see, oh, there's a COOH. This now we know is a carboxylic acid. So it'll end with anoic acid. But when we name, let's name this thing. How do we name it? We count the carbons. How many carbons? 1, 2, which is anoic acid, isn't it? Welcome. Welcome to class. It's good to have. Whoa, you too. Welcome to class. Get yourself a booklet. Why are you guys laughing? You excited to see your friends? Listen, yeah, please don't be late. And start speaking to people. Maurice, I'm working. Just so you two know, this is live recording for YouTube. Okay, so thank you. All right. Anyway. Yeah, so just a reminder, if you do disturb the class, your name will be mentioned and put on YouTube for everyone to see, including your parents. All right, so let's carry on. Where was I? See, now, I don't know. Where was I? Yeah, nowhere. Nice one. Okay, nice one. Proton donor. Yes, oh yeah, we were naming this. So how many carbons? Meth, eth, 2 carbons in the chain, longest chain. And we know, oh look, but it's got this carboxyl group at the end, so it is anoic acid, so if anoic acid. But let's take a look here up here by the ester. A more advanced naming, we're not going to get to it now. Okay, I'll explain to you later how to do this, like way later. So we can deal with that more later in its own section. Now these two we're going to combine as well. Let's call that B and B. What do aldehydes and ketones, looking at this functional group here, what do they have in common? Which is called what? They got both have carbonyl groups. But what is different about them? It shows you. Yes. Okay. So Joshua said that this carbonyl group will always have a hydrogen attached to it, meaning it's like at the end of a chain. But this carbonyl group will be between 2 carbons. So that's how you know the difference. Aldehyde and ketone. And how do you, what's the trick to remember this? Check this out. Please, doesn't like it, say. Like and subscribe for more videos, guys. Check this out. Hydrogen. Hey? Come on, guys. Okay, thanks for the laughter. Makes me feel good. And ketone is just the other one. All right, how do we remember this? So, no, seriously, you guys have to write this down. Hydrogen, hey? That's how you remember. So we know carboxylic acid. Acid's got the hydrogen, and the same thing here with hydrogen at the end there. Guys, you don't understand how valuable this stuff is. You don't know what you don't know until you don't know it. Doesn't make sense. Let's go on. And they have ways to name. We'll get to that later. All right. So that was basically the end of the summary of how these things work. So let me see if I can end this video by just destroying the